This is a training video for the product Q Prime formulations located at www.abmark.com on the paid products page. This product consists of 7 individual sheets titled Cylindrical Plunge, Cylindrical Traverse, Surface Reciprocating, Q Prime Plunge, Q Prime Traverse, and Q Prime Surface. This product was developed because I'm asked about Q Prime all the time, and I use Q Prime every day in my work. Q Prime allows a user, engineer, salesperson, job estimator, manufacturing manager, supervisor, and grinding operator to develop feed rates and thus cycle times for any product as long as they have diameter for a cylindrical part and infeed for surface grinding. This product is user-friendly and allows for the practical use and understanding of the Q Prime. My presentation will be to review pre-prepared demos for each process. So we'll start first with the cylindrical plunge. This is for grinding steel only, and remember, no calculations other than the cycle times and Q Prime formulations. Our first choice is to determine whether we want inch or millimeter, and I've chosen inch. Second choice is a choice of OD or ID, and I've chosen OD. The next is grit size. As you can see, I've chosen 80 to 100, but we can move any particular grit size we want, and we'll come back to that. The starting diameter is 2 inches for the input. The stock removal is 15 thousandths. The wheel diameter is 20. The wheel width is 1. The work width is 2. The wheel RPM is 1600, which computes to 8,378 surface foot. The actual RPM is 160 because I input that based on the pre-calculated suggested surface foot for the part, or RPM for the part, which computes to 84 surface feet, which is a 100-to-1 wheel-to-work ratio. The suggested wheel-to-work ratio was also 100, and the infeed is 20 thousandths. Now, had I changed from OD, let's say, to ID, instantly you'll see that we have a statement comes up, important, the wheel diameter is too large for the ID because we input a 2-inch diameter part and we have a 20-inch diameter wheel. So let's go back to the OD, so now we're back to normal. And I want to just show you some things. If we were to change the wheel RPM to 2000, you would see how we would automatically change the surface foot and the wheel to work ratio. So I'm going to go back to 1600. And if we had gone to ID, you'll notice that the suggested work RPM is 320. That's based on the 2-inch diameter we input. And our wheel to work ratio is recommended at 50, not for 100. The calculations at the bottom, I have input even the formulation for Q Prime, which is something I'm so hard trying to get out to the public. And in this particular case, on plunge grinding, it's Q Prime equals the part diameter times pi times the infeed rate, either inches per minute or millimeters per minute. Since we determined that we were going with inch as the dominant, you can see we had a choice. Had we gone to millimeters, inch would have been the secondary and millimeter the dominant. We see that everything is now computed in inches. So based on the input that we have above, the calculated Q prime, or cubic inch per inch minute, is 0.13. If we were to convert that to millimeters, which would be cubic millimeters, millimeters second, it's 1.34. Just for something for you to know, going from cubic inch to cubic millimeters, because we're going from minute to second and inch to millimeter, the factor is 10.7. So we would multiply the 13 times 10.7 would equal the same as going through the entire calculation. Very importantly, the percentage of abrasive grain per revolution of work is shown. We really never want to go above 15%. You can do this in certain cases, but at 15% and above, you really have a good chance, depending on the bond system, of extracting or pulling the abrasive out of the bond, thus causing what we call breakout. To show you how this would work, let's say we would change the 80 to 100 grit to say 230, 270. Now we're at 5%. But if we were to change, say, to the 80,000s, which is suggested under vitrified CBN, and as you can see, that would put us over the 15. So I'll go to 80 thou, and you would see a critical number coming up that now we have indicated that we're too high relative to the percentage of abrasive grain. It's now 20, 19.89, this is rounded up. We'll move this back to the 20, which is originally what was input. Now you'll see that the recommended feed rates based on the Q prime for conventional would be 0.15 Q prime, for ceramics like seeded gel 0.2, vitrified CBN at 0.5, and a new product called the Maximizer and Maximizer ST, which is also vitrified CBN at 0.3. These don't mean that they're maximum. These mean that these are very safe recommended Q primes. And again, as I told you, as you change your diameter, you change your infeed. You'll see this in a few minutes. So based on this is the abrasive grit size that we'd be looking at based on what we've input, based on the 230, 270. However, that's way too fine. Let's go back to the 8100. Now things fall into line. So cycle time hasn't changed, just our percentage of abrasive grit Q primes haven't changed. Grit size infeed hasn't changed. But now we notice that based on the present infeed rate, we're running at 45 seconds. The recommended conventional abrasive, if we input the correct numbers, which would be 24 thousandths, would be 38 seconds. And we go down the line, ceramic 28, recommended high concentration CBN 11 seconds, recommended the Maximizer ST 19 seconds. Going to cylindrical traverse, you'll see I'm going to stop and go down in the Q prime formulation, and you'll notice that now we're using part diameter times pi times infeed times the work RPM. So we have another factor when we go into traverse grind than what we had with the plunge grind. Again, we picked inch. We had a choice of millimeter and inch. This time we picked OD versus ID. I want to show what happens. I want to describe peel grinding. The reason I input peel grinding is peel grinding is like turning, but you're using a grinding wheel. The wheel is usually thin, somewhere around 1/4 to 1/2 inch, and the front face that goes into the part for cutting has an angle, and that angle is whatever depth or set at a depth that you're going to be taking off. And the material removal is always the full amount of stock. So if you're taking off 10 thousandths, 20 thousandths, 50 thousandths, whatever, you infeed the full amount, and then your traverse rate determines what your Q prime. You're also running at a speed that's very high, where conventional grinding is 65 to say 8500, and CBN is 8500 to say 12,000. In peel grinding, it starts at 17,000. It can easily go up to the 27 to 30,000 surface foot. So if we were to pick peel grinding, and now you would notice that all these numbers here, watch what happens. They become not applicable. We have to take these out because we are no longer looking at a typical infeed relative to grit size, because we're actually acting in more of a milling application. That's a whole nother subject, but we can discuss that at a later date. And you'll also notice that because now the suggested wheel to work ratio is 10 to 25, the potential is that the workhead speed would not be able to achieve those numbers, and that's why you'll see PO work RPM may be an issue. We'll go back to the OD, and again, you'll see what was actually created, what that means, what percentage of abrasive grit size, what the suggested traverse rate is relative to infeed rate, what the suggested Q primes would be, what the recommended traverse rate would be, and what the actual cycle times would be in seconds, along with another factor is the percentage of wheel width, the contact width, relative to the revolution of the work. In the program up above, where we put the input from the customer, we find that the traverse rate is running at 31.3% of the wheel width per revolution of the part. In the recommended, it's always at 40. That's a good starting point. When we're doing finishing, we could be less, but this is just something to give as some starting point. And for the cycle time based on the test endpoint, 69.4. The test input is something that I entered just so you can put data without changing all the other data. Example, we changed the RPM of the work to 360, which changed the percentage of abrasive grit size. If we were to go back and change that back to 160, we'd be back, I guess 160 would be the way, what do we do here? I have something that did, we had the traverse rate is too high. Put the traverse rate back to 100, then we'd be back to exactly the same as before. Now our recommended vitrified seconds, the 29, what you see in the test is faster. And that's because of the amount of material and what we're trying to take off relative to the passes. If we went back and changed this back to 0.0007 inches per pass, then they would be exactly the same, both the base present and the test area. It's just something to give the user the opportunity to make changes without doing everything from the beginning. Surface grinding. Now in surface grinding, our concern is two things: the depth of the cut and the traverse rate. Q prime equals depth of cut per pass times the traverse rate. Again, in this one we went a little more opportunity where we now still have millimeter and inch. I picked inch. We now have steel and carbide. We picked carbide or steel. We now have similar to PO grinding in the fact that it's a milling application because we're taking such a deep cut. We have both conventional surface, which is a pendulum type, and a creep feed where we're removing all the material at one time. So we'll see what happens when we hit the creep feed, much like before. We have a change in what's available and what isn't. Plus, the most important is the minimum power needed based on the wheel width. Now, if we were to change the wheel spindle power to, say, 10, then we would show that based on this width of contact, that's very critical, the P-line contact between the wheel and the work, we would need 25 horsepower. If we go back to the conventional, we don't need that much, so it becomes a non-entity. The percentage of abrasive grain based on the input is at 10%. The present based Q prime is 0.1, cubic millimeters 1.07. Carbide is not applicable because we didn't choose carbide. Recommended Q prime for steel 0.4, 4.28. And based on the in-feed rate, the traverse rate would be 800. If we were to exceed that, you would have a statement that comes up that says, typically the traverse rate of most reciprocating surface grinders are 1,200 inches per minute or less. So if you exceed that amount, there would be a little statement would come out that perhaps you're going faster than what would be capable, which means then you have an opportunity of slowing the traverse down and increasing the in-feed rate as long as you don't have a problem with the percentage of abrasive grain per cut or pass. Now I've taken you through plunge grinding, traverse grinding, and surface grinding. And I thought I'd put together some really quick ones for you where we look at Q plunge, Q traverse, Q surface, and I have a nice little trick at the end. But we'll take just now the cylindrical plunge grinding. And I've broken this down into inch and to metric. So I've set this up so they're basically duplicate. We're starting out with a 2-inch diameter part at 20 thousandths inch in feet per minute at a Q prime of 1.3. Using pi, which would always be the same, pi, we would see that the calculation shows that we would need to be right at the 20 thousandths to create the 1.3. Now we can change this and say, let's make this 0.5 Q prime. What would happen if we put 0.5 Q prime? Well, the pi stayed the same. So the only thing that's changed now is the 80 thousandths versus 20. If we were to change this to 80, it goes to 50. And this is just nothing more than doing the same thing in metric, where we multiplied by 25.4. And as I indicated before, if we went back to the original 20, which is exact duplicate of what's below, the 0.13 times the 10.7 computes to 1.35. That's the comparison between inch and millimeter. Now what I've done here is also given you the opportunity to see not just millimeter per minute, but millimeter per second, because a lot of people use that input. And I've put the actual formulations for everything on the right-hand side. Then for traverse, the same thing. We won't go into great detail since we've seen this, but again, the 2-inch, which is the part, the work RPM, the depth of cut, the Q prime, and the same for the millimeters or the metric system. Again, we're using the same 0.7 to 7.5. Everything's the same except one's been utilizing the 25.4 for the millimeters as opposed to the cubic inch per inch minute. And then for surface grinding, again the same. I've added one more thing, and that's millimeters per minute, millimeters per second, meters per minute. And given you again the formulations that we use. And again, everything in these are the same. So now we have one for plunge grinding, one for traverse grinding, one for surface grinding. So you can very quickly, when you're doing you have a new part, or you're looking at a part, or can we maximize the part? What happens if we change the Q prime? So we decide we want to go to 0.75. So we input 0.75. What does that mean? Well, that means we're going to have to now go at 750 inches per minute, or 63 feet per minute. Just to give you an idea. Or what happens if we change the infeed to 0.0007? Anyway, this makes it so much simpler for you to put these inputs and see what the results are. The final sheet is something that was developed. I developed for a customer, and it's very helpful if you want to do some estimating of a variety of parts. I'm going to do this for a lot of different areas, but for now it's strictly cylindrical OD/ID, plunge grinding only. But you get not only your machine time it can be input, your total cycle time, everything is set up for you, including what feed rates for each rough, medium, and finish. All of it is input and even recommended for the dwell time. So we have a choice at the top of inch or millimeter. Now we've put in inch, and you see the second drop-down box says not applicable, and the third now says cubic inch per inch minute, which would be inch. If we had chosen millimeters, then that would have blanked out where it says cubic inch per inch minute. Inch minute, and the cubic millimeters per millimeter second would have shown. So then we can put up to 3 drawings, 3 parts, whatever you're working on. You can go with OD or ID, chosen OD. It won't make any difference because it's just for something for you to keep track of when you make copies. And then you can choose. Maybe one part's 2-inch diameter, the next one's 3-inch diameter, the next one's 10. This is where Q prime is so nice, because the reason the Q prime works is you don't have to guess. You don't have to check anything. Know your Q prime, use your Q prime, and your feed rates, thus your cycle times, will be set. So in a 2-inch part, we kept the machine time 30 seconds, 30 seconds, 30 seconds. Stock removal, input, you can change this, 15 thousandths, 15 thousandths, 15 thousandths. But look, with the 2-inch at a 0.5 Q prime, our feed rate is 80 thousandths. On 3-inch, 53 thousandths. At 10-inch, 16 thousandths. So our cycle time, same Q prime, same machine time, same dwell times, same amount of stock. Now go with the machine not knowing any different between one part to another, meaning that with the Q prime, you now know what feed rates you can use without causing issues. You're now showing a 38.2 second cycle time for the 2-inch, 3-inch is 41.3, 10-inch is 63.1 as we reduce the amount of infeed based on the diameter of the part. Now, if you need more comprehensive and detailed processes for any and all of your grinding needs than what you find on these sheets, I'm going to direct you to the engineering software on our website at www.admart.com, and this product is available for subscription. Extremely comprehensible, and we're going to take a detailed and have audio video for that in the near future. If you need anything, have any questions or need any answers, please contact myself, Dale Savington, at www.admart.com, and on the Contact Us portion of any page. Thank you.